Here in Chapter 12, we're going to take a look at understanding research results. There are going to be some spots that I go through rather quickly because it's information that we've talked about in stats class. And also there'll be some information that we don't cover because I don't feel like we need to get into some advanced topics like multiple regression or effect size right now. I may talk about them broadly and briefly, but we're not going to focus on them so much. So let's take a look at the objectives and hop into the lecture. Some objectives that we have here that we're going to contrast the 3 ways of describing results using comparing group percentages, correlating scores, and comparing group means. We'll do all these things in stats class too. We're also going to talk about describing the frequency distribution, including different ways to display a frequency distribution, which was what we've done before in stats class, but we're going to take a look at pie charts and bar charts in this chapter as well, because this is a broad research course. It's not going to get a specific design, so it kind of does things broadly there. We're going to talk about measures of central tendency and variability, which we know. We're going to look at correlation coefficient, and we might skim past effect size and regression equations just as far as prediction. We'll probably stop at that point, though. So here's a review of the levels of measurement. We know these from stats class, but this is a good review for you. What you'll want to know is that the interval and ratio levels of measurement, those are also called scale for the purposes of our learning, because they use the term scale in SPSS and in many other disciplines to describe any variable that is interval or ratio. So you'll remember that. So how do we describe our results? Well, there are 3 different kinds of ways that we do that, and really 2. We're looking at individual scores being correlated or comparing group means, which is about the same as doing group percentages. The difference there is that instead of looking at the difference between the group means, which we do for t-tests and z-tests in stats class, comparing group percentages is more about descriptive statistics, like looking at a histogram. Generally, there are several different kinds of charts and graphs that we rely on. There are many more than this, by the way, but these are some fairly common ones. We have a pie chart, which is where we look at the distribution of a nominal variable. So if you wanted to look at a pie chart that looked at the distribution of race or ethnicity in a given group of people, you can identify that based on a pie chart. Bar graphs are, again, the same way, used to determine the frequency of a nominal variable. So you could use a pie chart if you wanted to know what part of the total that a certain group occupies, or you could use a bar chart to figure out which group has the most frequency in it. A frequency polygon and a histogram kind of go together. We know what a histogram is, but a frequency polygon is essentially drawing lines that connect the frequencies for each value that we have in a histogram, as opposed to using bars. So we're going to take a look at some examples of those real quick. This is a pie chart of the total people who like to travel compared to those who don't like to travel. And you can see here that a pie chart is simply just a segment that is relative to the percentage that it occupies. Nothing too extravagant going on here. A bar chart does the same thing that a pie chart does, but instead of using a part of a total, it just shows which has the most frequency for the given category. So this is still 70% of people like to travel and 30% of people dislike to travel, but it's presented in a different way depending on what you want the meaning to look like. In the pie chart, this is a part of a whole. And in the bar chart, this is which has the most frequency. So it's a way for us to look at the mode, for example. Now, if we wanted to use a scale variable to look at the differences in some kind of outcome, we could use numbers that relate to a frequency histogram. So if we have 2 groups of people, one group is modeled aggressive behavior. Another group is not modeled aggressive behavior. Maybe recognizes from the Bobo the Clown experiment. The modeled group has a mean, which is represented by X bar here. We would recognize that as a capital M. The mean is 5.20. on the frequency of aggressive behaviors. And for the no model group, the mean would be 3.1. We can look at that in terms of a frequency histogram like this. So this would be the frequency of the aggressive measure for those in the model group. So we had, for people who had an aggressive number of 3, or a score on the aggressive measure, you'd have a score of 3, and one person would have that score. One person would have a score of 4. 4 people would have a score of 5, and 3 people would have a score of 6. One would have a score of 7. That's indicated also by a frequency polygon. So the information in the in the model group that we just looked at can also be represented using this dotted line that connects the dots that represent the frequencies for each category in the previous slide. The no model group is represented on top of that. So what we can see is that in general, the scores for the group that was not modeled aggressive behavior are lower than those that were modeled behavior. We might recognize this almost as two curves that overlap but have means that are different from one another. We remember from this slide that the mean for the model group was 5.2 and the mean for the no model group was 3.1, which is indicated here as 5.2 is approximately here and 3.1 is approximately here. So those kind of fall toward the middle of those curves. Now the next section that we're going to take a look at is descriptive statistics, but we're not going to spend hardly any time on this at all because we did talk a lot about this in stats class, and it continues to be something that comes up in stats class, so we're not going to go over it too much. Suffice it to say that we are interested in central tendency, which is mean, median, and mode. And let me bump these all over a little bit. That'll make life a little easier. So mean, median, and mode. Maybe I'll put a space there. Look at me editing on the fly. We have mean, median, and mode. We're familiar with those. If you're not familiar with those, I encourage you to go review that from stats class. We're not going to spend a lot of time on it here. Same thing with variability. We have 2 measures of variability. We have standard deviation, 3, standard deviation, variance, and range. Range is technically a part of variability, even though we kind of consider it something different. So standard deviation, again, is the average amount of spread that a group of scores has. So just keep that in mind. I'm not going to, again, go over this too much. Let's move on then to correlation coefficients. We've talked a little bit about this in a prior chapter, and we will talk about this in stats class. So a correlation coefficient is a number between -1 and +1 that describes how correlated 2 numbers are, or two, well, technically it is 2 numbers, but 2 variables are. We get scatter plots as a result of this. We're not going to go over a lot of the calculations here on how to do that because we will do it in stats. So let's take a look at a quick example of how we might see a correlation. Let's say that we have 10 people, so there are 10 people in our study, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Each person is assigned a seating number. And the seating number really just corresponds to the row in the classroom that they're in. So maybe there's a theory that the closer you are to the front of the room, the better your scores are on an exam. So they list which seat each person is in and then what their exam score is. And they want to see if there is a correlation between the row number that you're in, the seating number that you have, and the exam score. And when we plot that on a scatter plot, it looks like this. So for the first person, they had a seating row of number 2 and an exam score of 95. So you go to their seating row of 2 and their exam score of 95. That is the first person, that 95 score. And you can find each one on here. And what we see here is that it looks like that there is a correlation of some kind between the seat and the row number, the seating number, and the exam score. You see how for the person who sits in the front row, the 2 people who sit in the front row, they have scores that are relatively close to one another. And they're all kind of like that, with the exception of row number 2. But you can also see that when this trend line is established, that it tends to go down, whereas the row number increases, the the exam score decreases. Almost forgot what we were measuring. The exam score decreases. That's a negative relationship or a negative correlation. So the correlation does come in positive and negative. So let's take a look at that real quick. So a positive correlation is when the score on one variable goes up, so does the other. So as one score on the x variable goes up, the y variable score is likely to go up by the same amount. That's a perfect positive correlation. A negative correlation is when as one variable increases, the other decreases. So as you go further away, or as your x variable gets bigger, your y variable gets smaller, and that leads to a negative correlation. These are just some examples of what a correlation coefficient might look like if it were graphed. There's missing data there. Boy, that didn't paste from the book. So there's mystery data here. I guess that's, oh, never mind. I'm sorry. That's from 12.2. So that is from this one. Sorry. Okay. Anyways, little brain hiccup there. We have a positive relationship. If it has a correlation coefficient of positive 0.65, that means that the relationship is positive and it's getting closer to 1, so it's kind of a stronger relationship. A negative relationship is negative 0.77, meaning that the relationship is negative so that the curve goes, or excuse me, not the curve, the scatter plot has a downward formation, and the number is getting closer to 1, even more so than 6.5, so it's closer to negative 0.1, so that means that it has a relatively strong relationship. And if you have no relationship, that means that there is no discernible direction of change that happens. And then the data from 12.2, which is what this data is, this has a negative 0.88 relationship. So it's a fairly strong negative relationship. So again, that's the pattern of relationship based on the strength and the direction. I think we're going to skip past restriction of range. Yeah, let's skip that. Okay. So you know what? Let's stop there, because this is something that's either review or something that we're going to cover in detail in stats class. So let's stop there. The importance of understanding the research results as far as the numbers are concerned is understanding that sometimes we look at group differences, sometimes we look at relationships between variables, but in any case we have to use the appropriate measure when we're looking at the research results. So when we look at research results, we need to be able to see that, okay, based on the results, this was a between subjects test because it was measuring group differences. Again, this is an introduction to the idea of understanding research results. We covered this more specifically in stats class, so we're not going to belabor that. So that's all we're going to cover for this chapter. I think that this will be sufficient for you to be able to do your article response. The article response has more to do with correlation than anything, so I think that you'll be able to get it. Even if you knew nothing about correlation, I'll bet you could do the article response based on logic and common sense. So if you have any questions, feel free to reach out. Otherwise, I look forward to seeing what you can do on your article response.